Welcome back to the Deep Dive. Today, we are really getting into something you probably use every single day, your iPhone 17.
Right.
But we're not just looking at the screen or, the camera. We're going deeper.
Much deeper.
Straight to the core. We want to figure out what really makes this thing tick. We're talking about the tiny chips inside.
The silent geniuses, as you called them.
Exactly. So, our mission today, find out just how many chips are packed into the iPhone 17 and why each one is so important. We're exploring the high-tech brain of Apple's latest. Okay, let's unpack this.
It really is quite something. Modern smartphone engineering,
Yeah.
it feels like this single, smooth thing in your hand, right?
Right.
But inside.
Yeah.
It's this incredibly complex world of tiny parts working together.
A miniature city, almost.
That's a good way to put it. And today we'll pull back the curtain on that city of silicon. You'll definitely see some surprising things about how they make these devices work so well. You'll have a new appreciation for sure.
I think I already do. And, okay, leading the charge, the big star inside the iPhone 17, there's the A19 Pro chip, right?
That's the one, the main brain.
We hear about Apple's A chips all the time. But what does it really do? Is it just about making things fast? Or is there more to it, like how it runs the whole show?
That's a great way to ask it because, yeah, it's way more than just speed. Think of it as the central command center, the brain, the nervous system, all of it.
Okay.
It's built by TSMC using their super advanced 3-nanometer N3P process, which sounds technical, but what it means is tiny. Unbelievably tiny component.
How tiny are we talking?
We're talking, well, over 20 billion transistors on that one single chip.
Wow, 20 billion.
Yep. And that's why it can handle, all the heavy lifting, running your app super fast, making games look incredible, even powering all those clever AI features right there on the phone.
So it does the thinking, the graphics, the AI.
Exactly. But here's the really key part. It's also designed for amazing power efficiency. That's critical for battery life, right?
Absolutely.
So because of the A19 Pro, your iPhone 17 runs smoother, faster, and cooler than ever before. It's kind of mind-blowing how one little piece coordinates so much activity.
Over 20 billion transistors. It's hard to even picture that scale. Feels like science fiction.
It really does.
But, okay, here's the kicker, right? The A19 Pro is powerful, yeah, but it's just the start. Most people, myself included probably, think, okay, there's one main chip, maybe two. You tap the screen, it works. Simple.
Seems that way.
But what if I told you the iPhone 17 actually has, get this, over 20 different chips inside, each one doing a specific critical job?
That's the surprising part for many people.
Yeah, this is where it gets really interesting for me. Can you maybe walk us through some of these other less famous chips hiding in there?
Absolutely. You called it a metropolis earlier, and that's perfect. The A19 Pro is the CEO, maybe? But it needs a whole specialized team because, no single chip can do everything perfectly efficiently.
Yeah.
So yeah, you have the A19 Pro, the application processor, but then you've got, say, the 5G modem that's likely from Qualcomm.
Dedicated just to the cell signal.
Exactly. Calls, data, streaming that chip, handles the connection. Then there's a separate Wi-Fi and Bluetooth chip for, Wi-Fi and Bluetooth, connecting to your network, your headphones, all that.
Okay, so specialized connectivity chips. What about memory?
Good question. Two main types there, each with its own silicon. You have DRAM, that's like the phone's short-term memory for apps that are actively running, and then NAND flash memory, that's your permanent storage. Photos, videos, apps, everything that stays when the phone's off.
Huh. It's fascinating how they break it down. Special chips for connection, special chips for memory. What about the things we experience more directly, like battery life?
Yeah.
Or the camera?
Ah, yes. More specialists. There's a PMIC, a power management IC. Its whole job is managing power flow. Super crucial for making the battery last. Without a really good PMIC, your phone would die incredibly quickly.
Okay, the unsung hero of battery life.
Totally. And for the camera, there's a dedicated ISP, an image signal processor. It takes the raw data from the camera sensor and turns it into those amazing photos and videos we expect. Noise reduction, color accuracy, focus, all handled by the ISP in real time.
Wow. So that's why iPhone photos look the way they do, not just the lens, but a dedicated chip.
A huge part of it, yeah. And even the screen needs its own boss, the display driver IC, or DDI. It translates signals into the image you see. Crisp, bright colors, thank the DDI, and sound. You've got an audio codec and a D-Day digital to analog converter to process audio for calls, music, everything.
So many specialized parts just for those core functions. And I guess there are chips for all the sensors, too, the ones that make the phone feel Where?
You got it. A whole suite of sensors, many with their own interface chips. Gyroscope, accelerometer, they detect motion, orientation. How does your phone know to rotate the screen? Those guys.
Yeah.
Then there's the ambient light sensor for auto brightness, proximity sensors for calls, and then the really advanced stuff, like the UWB chip ultra wideband. That's for super precise location, like finding your AirTags.
Ah,
And critically, the secure enclave, a totally separate lockdown chip just for security. It guards your Face ID, your fingerprint data, your passwords. Super important.
right.
Each chip is tiny, right?
Right.
But put them all together. That's how you get that smooth, intuitive iPhone experience. It's like this perfectly choreographed dance happening inside your pocket.
A silent dance.
Yeah.
It's incredible.
Okay.
So this orchestra of silicon, where does it all come from? Apple designs the A19, we know that, but they can't be making all 20-plus chips themselves, can they?
No, absolutely not. And that touches on something really important about modern tech.
Supply chain.
Exactly. The iPhone 17 isn't just a product. It's like a testament to global semiconductor collaboration. Apple designs key parts, sure, like the A19 Pro, but the actual manufacturing, that's a worldwide effort.
So who makes what?
Well, the A19 Pro, the brain, that's manufactured by TSMC in Taiwan. They're the world leaders in making these incredibly advanced chips using that 3-nanometer process we mentioned.
Okay, TSMC for the main processor. What about something like the modem, the 5G connection?
For that crucial part, Apple relies on Qualcomm, an American company, giants in wireless tech. They provide the 5G modem chip.
Right, so Apple designs, TSMC builds the brain, Qualcomm handles the connection. It really is a global team effort.
It absolutely is. And it highlights how complex and, frankly, how potentially fragile these supply chains can be. Any disruption anywhere, it can have big ripple effects.
That's a really interesting point. So even with Apple designing the A19, they still need these other huge companies for essential bits like the modem. What about, say, memory? Or the camera sensor, different players there too.
Oh, yeah, definitely. For memory, both the DRAM and the NAND flash storage, you're often looking at suppliers like SK Hynix or Samsung, both based in South Korea. Huge memory manufacturers.
Okay, Korea for memory. Camera.
The camera sensors themselves, very often Sony from Japan, they're masters of image sensor technology.
Japan for the sensors. Wow.
And it keeps going. Audio chips might come from Cirrus Logic, Wi-Fi, and other connectivity chips. Often Broadcom. It's this intricate global network of specialists, each bringing their best-in-class technology. That collaboration is what makes the iPhone so capable.
It paints such a clear picture. Not just Apple, but this web of global experts. Which leads me to wonder, with all these different specialized parts, why not just simplify? Why not aim for one giant super chip that does everything? It feels like it would be less complicated.
It's a totally logical question. Seems simpler on the surface, right?
Yeah.
But the answer really comes down to two key things: optimization and modular design.
Okay, break that down. Optimization.
Think about it. A chip designed only to manage power can be made incredibly efficient at just that job. It doesn't need the massive processing cores of the A19, for example. So by specializing each chip, you get better performance for that specific task, better thermal control. The phone doesn't overheat as easily, and often it's more cost-effective, too. You're getting the best tool for each specific job.
Ah, I see. So instead of one chip doing everything okay, you have lots of chips doing their one thing perfectly.
Pretty much, yeah. And the second part, modularity, is also huge.
How so?
It gives Apple flexibility. Maybe the iPhone 17 Pro gets a slightly fancier camera processing chip than the standard iPhone 17, but they can still share the same modem, the same Wi-Fi chip, the same power management chip.
Ah, so they can mix and match components for different models?
Exactly. It streamlines design and manufacturing. Plus, from a supply chain view, working with multiple specialized vendors is often safer and more efficient than relying on one single manufacturer for a hypothetical massive super chip.
Right. Don't put all your eggs in one basket.
Precisely. So this complexity, all these different chips, it's actually how Apple manages to balance everything. The power, the battery life, the cost, the performance. It's complex, but it works.
That makes a lot of sense. It's intentional complexity, not just messiness. Okay, so looking forward then, we have this intricate system in the iPhone 17. What's next? Where does chip technology go from here, especially for phones?
Oh, the pace is just relentless. The next big step everyone's watching is the move from 3-nanometer, like in the A19 Pro, down to 2-nanometer chips.
Even smaller.
Even smaller. We're expecting those probably around the iPhone 18 timeframe, maybe 2026. That means potentially even more power, more efficiency packed into that tiny space.
What else? Is it just about getting smaller?
Not entirely. There's a huge focus now on AI-specific hardware. Chips or parts of chips designed just for machine learning tasks. Think smarter voice assistants, way more advanced photo processing, better predictive text, all happening faster and more efficiently right on your device without needing the cloud as much.
On-device AI. That sounds big.
It is. And then there's how the chips are actually put together. We're seeing more interest in chiplet architectures.
Chiplets.
Yeah, instead of one big monolithic chip, you make smaller, specialized chiplets, maybe a CPU chiplet, a GPU chiplet, an AI chiplet, and then you package them together. It can be more flexible, potentially cheaper to make.
Interesting. Like tiny Lego bricks of processing power?
Kind of, yeah. And related to that are new ways to package them. Things like 3D stacking, where you stack chips vertically, or advanced techniques like NFO integrated fan-out that allow for denser connections.
Yeah.
Apple and TSMC are really pushing the boundaries here. It all points towards smartphones getting even smarter, more powerful, and somehow maybe even smaller or more efficient.
So now you know your iPhone 17 isn't just a sleek gadget. It's really a semiconductor masterpiece.
It truly is.
From that powerhouse A19 Pro running the show to that hidden team of over 20 specialized chips, each doing its critical part, and all brought together by this incredible global network of companies. It's just an amazing amount of engineering and teamwork packed into something you hold in your hand. So next time you unlock your phone, maybe take a second. Remember, you're holding the result of, countless engineers, literally billions of transistors, decades of innovation. Right there. Makes you wonder, doesn't it? With this constant push for smaller, faster, smarter.
Sure.
What incredible new things will this miniaturization unlock next?
It really is humbling when you think about the scale of it all. The ingenuity packed into these devices is just staggering. And the field keeps changing so fast, there's always something new just around the corner. Always more to discover.